You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Since its inception, Amazon Web Services, AWS, has been the best place for customers to build and run open source software in the cloud. AWS is proud to support open source projects, foundations, and partners.
Hey everyone, we are here from sunny Bilbao, Spain at the Open Source Summit, and I'm here with Jonathan Katz. Hey Jonathan, how are you?
I'm great. I'm well. How are you today?
Very well. Jonathan is Principal Product Manager, Technical, Amazon RDS and PostgreSQL, which is a lot. There's more though. He's also a core team member at Amazon Web Services on the Postgres project.
Mm-hmm. Well, I'm a core team member on the Postgres project. That's independent of Amazon Web Services.
Okay.
Because it's the open source project.
Okay, good. Well, there we go.
Yeah.
Thank you for the clarification.
You're welcome.
So welcome, and I would love
you.
to just get right into it. I want to kind of give you kind of a picture of what I'd like to discuss, okay? So I wanted to get into PostgreSQL 16, which has just been released.
Yeah.
And for those unfamiliar, Postgres is an open source relational database management system. Mm-hmm. I think most of our viewers here know what that is, but it's always good to explain it a little bit.
I was going to say, it wasn't always the case. Postgres is certainly well known now, but back when it started, it was fairly niche. There were other relational database systems out there, both open source and commercial. So
yeah.
For me, it's 10 years ago, I would tell people, I use Postgres, I'm active in the Postgres open source community. And the first question would be, well, what's Postgres? And even my parents had no idea what I did. But then, as time has progressed, my parents would be in business meetings talking about Postgres. So
really?
I'm yeah, that's kind of cool, right? That it's coming up in their world now.
When do you think it really started to boom? For me, I think about 2017, 2018 timeframe.
Yeah, I think it was a little bit earlier. But definitely by 2017, 2018, it was everyone was building something with it. I think probably in the the early 2010s, there was a lot of different things happened at that time.
Yeah.
There was some changes in the database landscape.
Yeah.
MySQL, moving between different companies caused people to look at different open source relational databases. But the feature set of Postgres caught up in many ways. It's one of the big missing features was a native replication solution in Postgres, or the ability to copy your data in real time, between other systems, used in high availability. Helping people maintain availability throughout different operations, and once those features were in place, people were looking to keep their data in Postgres.
So, I'm curious then about Postgres and where it's going from here.
Yeah.
So we'll get into that a little bit. What are some of the use cases it's solving, and what are some of the emerging use cases?
Yeah, that's a great one. I hate giving the answer of you can use it for everything, because it's always good to use the right tool for the right system.
Right.
But relational databases tend to be general purpose, so
right.
They're used in all different industries, all different verticals for all different things. I mean, ranging from academic apps. I'm testing something out to mission critical systems, and it's been used for everything, whether it's traditional applications or. I would say, going back to the early 2010s when JSON emerged as the language of the web, people were taking their JSON documents and storing and searching them in Postgres. I talked to one of our customers where they have over 40 terabytes of JSON documents in a single Postgres database, which to me still fascinates me. Merging, there's all sorts of different places to go in terms of what's emerging.
Just a terabyte, one would be enough. 40.
It's hard for me. I still can't imagine. I still can't imagine a terabyte. I know it's very easy to get to that these days, but 40 terabytes just blows my mind.
Do you remember when computers started to go from megabytes, gigabytes? You're why would I need that? That's amazing.
640K. That's all you needed.
Yeah. So I also would like to touch on Amazon RDS. Mm-hmm. And its evolution with Postgres. And of course, I want to learn a little bit about yourself and your approach to managing large projects like Postgres. So.
Sure. So all different things. I mean, let's start with Postgres. So Postgres is, it's a large project in the sense it's very widely used, but if you look at, the contributors, I think in the Postgres 16 release there were over 350 contributors, which is, quite a bit. And, and that pool continues to grow. But there's only 31 people who can actually commit code to the Postgres database.
Only 31
Only
people.
31 people. Yeah, it takes many years of training to become a committer. I know other projects call them maintainers. We call them committers. And
for reasons that go back a long time ago.
Predate me. Yeah, but well, I think
we're going to be committers.
Yeah. Well, yeah, because it was literally you got your commit bits, back when they were using a CVS to commit the code, and then things ultimately moved to Git, and of course you have Git commit, right?
So maintainers? No, we're committers.
We're committers. Yeah.
Right,
well, I'm not a committer personally, but
you're not.
No, and that's where I'm involved, right? When I first got involved in the project, I was an app developer. I just wrote SQL, and I thought like, oh, cool, people get involved in Postgres because they write SQL. Well, people got involved in Postgres because they love database internals and building search systems, as I quickly learned. And there was just so many talented developers working on it. To me, I felt personally where I could be most helpful was working on the non-development work. I had experience organizing events. I used to, in college I organized actually startup events, and I tried to carry that over into the open source communities.
At Tufts?
At Tufts, yeah. And I helped organize the local New York City user group, and ultimately that we started organizing an annual event around that. And that's where I started in the community, because while a lot of the Postgres community operates on mailing list, a lot of like the brainstorming and the connection building occurs at the events. There's no substitute for that.
That's great about being in New York, right? I mean, you can find a few people who are interested in Postgres, and maybe a few more. Yeah. Before you know it, you have a lot of people involved.
Yeah, I mean, we were I think we still are the largest Postgres local community in the world, but it's also kind of a cheat code because you're in New York.
Congratulations on that.
Thank you. Yeah, I mean, it's easy when you're in one of the biggest cities in the world. You can get that critical mass.
Yeah. Tufts doesn't strike me as a computer science school, is it?
Yeah, I mean, I had a CS major there, and it was I loved it. My advisor is Alva Couch. I loved working with him, and actually we did some research.
Who's that? I don't know him.
He's I haven't talked to him in a couple of years, but I think he's still an associate professor. He studied actually his focus of research was systems administration, large-scale network research. And when I was doing some research on him, I actually used Postgres as the database to store information.
So you were checking out SQL, and you found like, hey, there's this deep world out there of people who really like to get into the particulars of database development. There's a lot of new particulars of database development in this new release. So some of the highlights I was reading about include, let me see here, database management, of course, some new standards for that. Some data replication systems monitoring features. Performance optimization. There's lots. And they could go on and on.
Yeah. Yeah, and I really like the logical replication features. I mean, I don't try to pick favorites, and it's I get to help write the release announcements, so I get a chance to review all the features. But the logical replication is very exciting because that's a way to be able to send data in real time streaming to downstream systems. They could be Postgres, they could be other completely different systems. As long as they can speak that protocol, you can extract that data anywhere and use it for different purposes. And one of the big use cases that we heard from customers, we heard from users as well, was being able to do that streaming from standby systems. So before Postgres 16, if you wanted to stream your data out, using logical replication, you had to do it from your primary. So that's your system accepting your reads and your write traffic. So a very busy system. But if you're able to offload that work to a standby, which is typically less busy, you're able to move some of that traffic away from your primary and effectively be able to scale your primary further. So it's a great scalability feature. And the work in the community actually started 5 years ago, which shows that it actually was a very hard feature to build. Yeah. And we actually, we made it a priority, we being the community, to be able to get this into Postgres 16 because we really heard from folks that they need it. They need to be able to have this feature to help continue to scale their workloads.
So 5 years.
5 years. Not every feature takes 5 years.
Why did it take 5 years?
Initially, it was a hard problem. There was a predecessor feature that needed to be built, and the community first had to settle on a design. And that's like actually one thing I really appreciate about the Postgres community is that some things do take a little bit of time, but there's just a lot of meticulous thought that's put into it because, understandably, when people adopt a database, it's kind of like adopting an operating system that you might be there for a while. You want to make sure that the feature you're using is stable and works over the long haul. So there was discussions on design, and it was challenging to code. One of the contributors who was at Amazon, undertook actively trying to do the development work from November till feature freeze, which was in April, and it really was like a lot of back and forth, working with other committers and contributors in the community to get it done. And that feature actually went up to the 11th hour before the feature freeze. That the committer who ultimately got it in just I don't know how many hours he put in that day just finalizing it, but it was a lot of work. And that's the great thing too, that if you look at all the different organizations and individuals contributing to Postgres, while it might not be their feature, they're active in the design and the review and working to be able to get it committed into the project.
Do you think that's unique? Or is it just a nice part of the community?
I think it's a nice part of the community. The community ethos is, it's very strong. That we're all in this together. We're all collaborating together, and everyone really wants the same thing: is they want Postgres to be successful.
So, help me out here. Now, you are talking about these features that took 5 years to build out, right? Mm-hmm. What are you building on now that's in progress that you're excited about? That's kind of like, that is taking those values that you have into consideration. Mm-hmm. High quality work, it seems like that's a real focus of the community. What are some of the projects you're doing now that you think are noteworthy for future releases?
Yeah, so I can do short to midterm, long term.
Let's hear it.
Do I hear?
Yeah.
How about let's do the long term one first. So
okay.
I think there's a feature a lot of people are excited for, and that's direct I/O. So the way Postgres, so the most important thing about a database is that it's got to be able to save the data to disk, and ideally you're going to save it durably to disk. That hey, I'm saving this integer to disk. It's it's pushed down to the disk. It's stored safely. If I try to retrieve it, it's going to be the same integer I get back. So for its history, Postgres has relied on the operating system to help with that. It leverages the fsync command in Linux, at least on Linux-based systems, to be able to ensure data is reliably written. And that has its advantages and its disadvantages. The advantage is it's much simpler. It's much simpler to implement, but there could be some performance trade-offs. And direct I/O is a way at enhancing the performance of being able to write to disk. There actually initial support for direct I/O was committed in Postgres 16, but it's not ready yet for production use. It was actually hidden behind a developer flag, and that's just to help continue the development on it for the next several years, because it's going to take time. I mean, this is arguably the most important functionality of a database is to be able to save data to disk. So the community is going to take its time rolling it out. But it's going to be exciting because once direct I/O is in, it's going to allow for additional work around the performance of writing data to disk, and that's going to take several years. But we've made a ton of progress over this.
Why
past
has that
release.
emerged as such a major use case?
Well, it's continuing to vertically scale. It's something Postgres has actually done very well throughout its history. Is that it's able to leverage all of its infrastructure available, to a degree. And you're able to basically store your data in one place without necessarily having to use like a horizontal scaling strategy or a sharding strategy. And there's many workloads that do, right? This gets back to Postgres being a general purpose database solution. Right. But it is, it does vertically scale very well. To continue doing that, it's going to need to be able to take advantage of things like, direct I/O and other features that will help continue to improve performance.
What will direct I/O do? What does it do exactly?
So direct I/O is the interface between the database system living in memory and your file system.
Okay.
And what it basically does is that it's the layer where you're you're basically transferring the information from disk into memory and vice versa.
Okay.
So instead of leveraging the operating system to do that as it does today, direct I/O basically eliminates one of those layers and allows you to interact directly with the file system. And like I said, there's trade-offs with that because you do have the advantage that if tuned well, written well, it does enhance the I/O communication layer. But there's more, there might be more knobs for the user to be able to tweak. And it's more work on the database system to maintain that because you don't leverage a lot of the nice features that are already built into Linux to help with that.
There's so much data too, right?
There's so much data too.
Yeah. All right. Now you have been working on these environment, on PostgreSQL for a while. Mm-hmm. So who do you work with on the projects? Who's part of your team, and and tell me a little bit about your role there and how you really got involved in it in the first place. You're talking about those early days in New York, but I'd love to hear your story.
Yeah. So I work all over the place in the project, by the nature of my role. As I mentioned, there's all these people who are, actively working on the C code. And, my role has been around the governance of the project. So I started out with events, helping to organize events, which led to me helping out with the website.
Okay.
And when we rebuilt the website, I think we relaunched it in, I must say 2018. I helped work with several folks on that. And it was funny, I was at an event where someone was talking about, the Postgres project, it's a bedrock of stability. The website has been the same design since 2003. And 15 minutes later, we pushed out the new change. So, we can do some things, at a, rapid pace in the community, at times. But, so from there, I'm generally involved in, I like to say release management, but really it's more, writing about the releases, handling, the release announcements, helping to coordinate activities there. Involved, in different, several of the nonprofit organizations, either around events or, community intellectual property. I'm on the security team, typically handling governance issues as they come out. But yeah, like I said, it's really all over the project. Pretty much. I mean, not everything, but a lot of the non-technical governance work, and coordinating different initiatives from there. And what's cool about that is I do get to work with a very wide group of folks in the community all over the world, and that's really the best part is hearing what people are working on, their ideas of the future. And some of it has guided me throughout my career. One of the Postgres committers, currently at Amazon, I've known him for well over a decade. He told me about this thing he was working on 10 years ago. It was called range types or temporal types, where you could store a range of data, like a date range, a numeric range, in a column and search over it. And he had it. It wasn't committed yet. It was an early idea of his. And I'm like, this is so cool. I know this is gonna be useful for me someday. And one of my startups I was at, that was the integral data type for our search. And I thank him to this very day for inventing it because it really did make a difference to me personally. And I think that's the coolest thing about working in the community is that you might just having these conversations with folks and learning new ideas of how you can build apps with them. It's pretty cool.
That's pretty neat, So you've learned a lot about yourself in the community through this whole process, haven't you? I mean, Postgres has really been such a core part of your career. And do you see it that way going forward? I guess you do.
Yeah. I mean, if I look at how long I've been alive versus how long I've been using Postgres, it's been more than half my life now. So I would say it has been pretty important.
You have friends all over the world, so.
Yeah, it's a good excuse to travel.
Do you get out a lot?
It depends. I mean, definitely in my younger days.
Yeah.
I still try to travel when I can.
Yeah.
We have a little kid now. So that.
Very cute.
Yeah. Thank you.
Now, you also work with the Amazon Relational Database Service, and that's a managed database service provided by AWS. And PostgreSQL is one of the database engine options available to use with Amazon RDS. So as I understand, the other options include MySQL, MariaDB, Oracle, Microsoft SQL Server, and Amazon Aurora. So what does PostgreSQL 16 offer Amazon RDS? What is it? What does it do for the service itself?
Yeah, so I think there's some great features in it that certainly help the different Postgres engines. I mentioned the logical replication features are great. I mean, they're one of my favorite, as I mentioned, is the being able to replicate from standbys, and That's going to help customers further scale out workloads. Another feature, parallel apply of large transactions. So what happens is that when you're streaming changes, that it arrives on a subscriber, and subscriber needs to replay those changes and put them into the their system. And if you get a very large transaction coming in, that could take a while because it needs to replay all those changes. So being able to leverage more CPU cores and apply that transaction more quickly helps to remove that bottleneck and speeds it up. So definitely excited for like the performance capabilities of that, how we can distribute that data.
Okay, so when you think about installation, on Amazon AWS and configuration and management of the overall environment, what is the impact there? Is there anything in particular that you see?
Yeah, so there's depending on the feature, there might be a few more configuration settings to set up, but that's part of the managed service. So we make those available.
Yeah. Okay. So tell me about the managed version of PostgreSQL and what you're offering there.
Yeah, so we have Amazon Aurora Postgres Compatible Edition and Amazon RDS for Postgres, and there's a lot of different features of the managed service that are able to help with common business operations, so high availability, continuous automated backups, monitoring, and things that make it similar to manage on a day-to-day basis. And for me, with my app developer background, what's nice about that is a lot of like the operational work. We don't, that's handled by the managed service, and then you can just focus on building the application.
That's key. I mean, I've talked with your other teams on managed services you offer for Flink, for example, and that's a core part of the managed service there, right? Mm-hmm. It's like taking the burden off so you can focus on your core kind of requirements that you're building. I'm curious about PostgreSQL with your managed service and PostgreSQL 16. Mm-hmm. Is there anything different there?
No, it's Postgres 16, so it's all the features that you'll see in Postgres 16.
Yeah. Well, Jonathan, thank you so much for taking the time to talk today. I've appreciated your time, and and it seems like you're having fun with the project. So keep on going there.
Yeah. Thank you, Alex.
Yeah,
it's been a pleasure.
Yeah, it's been fun. If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.